Welcome to True Projects. In this video, we are going to explain about a project titled Pneumonia Detection Proposing a Hybrid Deep Convolutional Neural Network based on 2 and ML. So now coming to the introduction part. Pneumonia represents a severe respiratory ailment marked by lung inflammation, frequently instigated by bacterial, viral or fungal agents. The prompt and precise identification of pneumonia holds utmost importance for efficient medical intervention and optimal patient treatment. In the modern era, the incorporation of cutting-edge technologies, notably deep learning and machine learning, has exhibited encouraging outcomes in streamlining the diagnostic procedure. So now coming to the objective part for this project is to progress the realm of pneumonia identification by suggesting a hybrid model that combines a deep convolutional neural network, that is DCNN, utilizing 2 separate architectures and conventional machine learning methods. The ultimate objective is to improve the precision and effectiveness of pneumonia diagnosis by synergistically incorporating the capability of deep learning in extracting image features and the interpretative capacity of machine learning algorithms in managing a variety of clinical data. So now coming to the requirements part, here we have 2 types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. This involves bringing in various libraries and tools necessary for the task ahead, such as data manipulation, machine learning and image processing. Common packages might include NumPy, Pandas, OpenCV, Philo, Scikit-learn, Keras and others. Exploring the dataset, chest, X-ray, image data. So in this, understand the dataset structure, contents and characteristics. This often includes examining the types of data available, checking for missing values and gaining insights into the distribution of classes in the case of a classification problem. Next, we have image processing using OpenCV and Philo. Utilize OpenCV and Philo for processing chest X-ray images. This may involve extracting features using OpenCV, converting images to array, and reshaping the data. Then here next we have splitting the dataset into training and testing. Divide the dataset into 2 parts, one for training the machine learning models and other for testing the trained models. This step ensures an unbiased evaluation of the model's performance. The next here we have building the ML model. Create machine learning models using various algorithms, that are support vector machine with radial Bayes function, kernel random forest, k-nearest neighbors, decision tree, multilayer perceptron, voting classifiers, image processing using image data augmentation with Keras as a backend. So in this, augment the image data using techniques like rotation, flipping and zooming to enhance the model's ability to generalize. Then next here we have data extraction to train and test. Extract relevant data from the pre-processed dataset for training and testing the deep learning models. Then we have model building. Construct deep learning models using various architectures, that are InceptionVC, MobileNet, AlexNet, BGG16 and BGG19, ResNet 50, DenseNet 121, QuizNet, BGG16 and BGG19 combined with SVM classifier. Then we have here building the model for predicting in front end. So in this, train the deep learning models using the training dataset and evaluate their performance on the test data. In this, we have to develop the necessary components to use the trained model for predictions in a front-end application. Then we have Flask framework with SQLite for sign-up and sign-in. Implement a web framework, that is Flask, along with the database SQLite to manage user authentication, allowing users to sign up and sign in. Next, we have user gives input. Users provide input likely in the form of uploading chest X-ray images for diagnosis. Then we have the given input is pre-processed for prediction. Pre-process the user input images, converting them into a format suitable for input into the trained models. Then we have trained model is used for prediction for about image. Apply the pre-trained machine learning and deep learning models to predict whether the input X-ray image indicates pneumonia. So here we have a folder which is named as template. This folder contains all the HTML pages which is used in this project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Another folder named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. And the file which is named as .ipynd file is a Python notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Then we have app.py file which likely contains information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Then here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path from here. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste this link over here and now hit the enter button. So here you can see that this is our homepage for the analysis about the pneumonia, image processing and deep learning. Now click on the sign up button. Enter your username, your full name, email, number and your password for doing the registration. I have already done the registration, so I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration and click on login button. Click on OK and here you can see upload your image to be classified. Click on choose file and upload the image. Let me just upload the image. So now here you can see that here I am selecting this image over here and click on open button. Now click on upload button over here. By scrolling down below, here you can see that it is showing the result for the uploaded image. The outcome is based on the chest X-ray input, the patient is normal. So depending upon the image you are providing over here, it will detect about the results. By clicking on the try again button, you can try with another pic. So just click on choose file again over here. Select this image and click on open button and click on upload. So again here it is detecting whether based on the chest X-ray input the patient is normal or not. Depending upon the image you are uploading over here, it will detect whether the patient is normal or not. And here you can see that there is a graph button. By clicking on it, here we can see many different graphs. So depending upon the graphs and the algorithms we are using over here, we will get the accuracy of those algorithms. Here you can see that we have a button for sign out. By clicking on this button, you can simply log out with this. Here you are successfully logged out with it. Now coming back to the slide. So now coming back to the conclusion part. In summary, the suggested hybrid model for identifying pneumonia, which merges a deep convolutional neural network, that is DCNN, utilizing two architectural designs with conventional machine learning methods, marks a substantial step forward in improving the precision and dependability of diagnostic processes. The use of dual DCNN methodologies enables a detailed examination of chest X-ray images, capturing a broad spectrum of features linked to pneumonia. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.